Hey, gonna do a quick little video thing here for you, give you some information before you move on and do more things. Yeah, so hopefully, like I said, you watch the Robert Waldo because that's important to what we're gonna do here. There's a couple things I mentioned that we were gonna talk about, and I wanted to make sure I reviewed those real quick. This is gonna take too long. One of them was called ratio. Okay, the whole idea of what a ratio is, and a ratio is just a comparison between two quantities. And we've talked about, we kind of did, I think, a little bit about ratios and proportions maybe. I'm not exactly sure. But that's what a ratio is. So when you're talking about what do you mean by comparison and what do we mean by two quantities? So if we were to talk about, for example, um, miles per hour is a ratio. And so if you're going 60 miles per hour, that's a ratio. All right. Many of you, when we had that like 2, 3 weeks, whatever it was, time off, did a lot of stuff with recipes. So when you do stuff with recipes, that's a perfect example of a ratio. Because if you made some bread, you maybe had to make 2 cups of flour, right, per what would they call that? I don't know if it would call it a serving or a batch or a loaf maybe, right? And so maybe you were going to make a larger amount, so then you would change the ratio, but that's still the same. Or even if you had 1.5 teaspoons, right? Okay, per serving or per loaf, something like that. Right? Anything that you're comparing, that's going to be a ratio. Right? So you could compare men to women, in a room, right? There's 15 to 10. Anything like that is a ratio. All right, so now we know what a ratio is. What about a proportion? Proportion. So a proportion is two equal ratios. And you've worked with proportions many times. So this particular skill that you learn mathematically is one of the most important skills you probably will learn because you're dealing with ratios a lot in a real life situation. The recipes is a perfect example of that. Right? If you've got to make more a batch or more than a loaf or more than a servings, you need more servings, then you need more stuff. And you got to figure out, well, what is that going to look like? So let's say we have a ratio of 3 to 5, right? But we need to double this 5, so we need to make it, well, let's say we're going to make it so that it's 9. All right, I need to know, well, how much is that top number going to be? All right, so we set up what we call a proportion. And then to solve a proportion, you always cross multiply. So we cross multiply here, we get 5x equals 27, and then we divide by 5, and we can get an answer. So I use my calculator, it should come out to be 5.4. Alright, so that is how you solve a proportion. And that's what you're going to be doing a lot of. Alright, we're going to be working with proportions. So let's take another one here, another proportion. I'm going to put down here 21 on the bottom, 21 down here on the bottom, okay? And this time I'm going to put 12 up here, and I want to know what that looks like. Again, we're going to cross multiply. All right, 12 times 21, 12 times 21 equals 8 cross, multiply, and divide. So I'm going to take the calculator. I'm going to multiply 12 times 21. 12 times 21. And divide that by 8. 31.5. So when I was trying to figure out, kind of what Robert would look like in the room, and I was taking him and I would stretch and move and try to get the same measurements, I did a lot of proportions. So I would take some measurements on me, take some measurements on the screen. So for example, one of the things that I did was I said, well, what if I had line about where I was figuring where he was, about mid-chest to top of my head, and I measured that, all right, and I got about 18 inches, and then I measured it on the screen to see what it was, and I got 3.5 inches. Okay, so I don't need the inch signs there. So I want to know, okay, well, what would Robert's technically look like? So I'm trying to line Robert up, right? So then I figured out that he was 27.5, about from that same measurement, mid-chest to top of his head, than what would have been like on the computer screen. So then I set up this proportion. So this is me over on this side, right? And this is Robert over on this side. So when you set up your proportions, all right, you have to make sure that you have them set up correctly. So here I have my real distance, right, over my screen distance equals, now I got to go with real here, and then I got to put screen here. I cannot mix and match them. Right, so I have to do it that way. So I just went ahead and figured it out and used cross multiply, and I came up with 4.9. So I set up a proportion for that. So another idea behind this whole ratio and proportion is scale factor. And we're going to talk a lot about scale factor. So what exactly is scale factor? Right, so that is is a number that represents how much smaller or bigger a pre-image and an image. So if we take scale factor is the value, it's a number, right? It's a value that describes how many times bigger an image is to the pre-image. That's basically what a scale factor is. So when do you use something like a scale factor? Well, for example, people that are architects, right, or engineers, or people that design anything are always using scale factor. And so if we take a look at, say you have a downtown development they're talking about. So if we have a path that goes around this way, and maybe goes this way, and then goes that way, right? So they say, well, this is what this is going to look like. Well, you can't really get an idea what it looks like. So then they take a rendering of it, and they say, well, it's really going to be how big out there in the real. So let's say that that is 110 feet, or actually probably be more like yards. All right, so this is 110 yards, okay? And then maybe this turn is 50, and maybe this turn is 40. But if I wanted to make a model of that, okay, so I'm going to make a model of this, then I'm going to use the whole idea of scale factor. So in this case, I'm going to scale this down. So I'm going to scale it down. So maybe I can put it and make a presentation, or maybe I can put it in the newspaper or something like that. So how much do I want to scale it down? Well, maybe I'm going to make it, 1/10. All right, so that would be my scale factor. Now, scale factor doesn't necessarily always have to be a big number. It can be a small number depending upon which way you're scaling it. So if we're going to scale this down, then we're going to say our scale factor is 1/10. So if I take the real, right, multiply it by the 1/10, that's the scale factor, that will give me the image. Or maybe even what we would say would be the model. So the real part would be the 110. All right, so that's going to be 110 times the scale factor is equal to then the image. So that's pretty easy to figure out. That's just going to be 11. All right, so I might scale it something like that. All right. And I just kind of made this stuff up a little bit. Actually, you wouldn't use 1/10 because it's not small enough. You have to scale it down way more. But if you were, because you wouldn't make an 11-yard model, it would be too much. But if you were to make a model of that, then you'd have to scale it way down. Right? So, and people do that kind of stuff all the time. So it's pretty similar to a proportion. You could set up a proportion on this, but sometimes we could use a scale factor. Right? So let's talk about Robert for a second, right? And that's what you're going to be doing here in a bit. Is you're going to be working through some things with him. So Robert, we know from the measurements, was 8.9 feet tall. That was his height. All right. So if we wanted to know, well, what if I wanted to scale him so that he was small, or what if I want to find the scale factor between Robert and myself? All right, so then I would have to take my height and figure out, well, what is that? All right, so then I would take, well, I know that I'm 5'10", right? So I'd have to convert that into a decimal. So that's 5 point, and then I have to take 10 and divide it by 12. So I'm going to take 10 inches, all right, divided by 12, and I get 0.83. So now I can find the scale factor. So I can look at how much bigger he was. Right? So I could take, to find the scale factor then between us, scale factor, I'm going to take his height divided by my height, and we'll find out what the scale factor is. Oops. 8.9 divided by 5.83 equals 13.5. Right. I got some problems here. 8.9 divided by 5.83 equals 1.53, we'll call it. So he is about 1.5 times bigger, according to height, than I am. All right. So now, well, how can I use that? Well, now that I know what the scale factor is between us, I should be able to figure out anything I want. So then if I, for example, say my shoulders across, all right, and I measured that, which I did actually, it was a little over 20, I think. It might have been the 30.5. I'm going to say 24. Okay, so let's say that was from shoulder to shoulder, here to here. Okay, it was 24, and I know that he is 1.5 times taller. I can just take that number, multiply it by 1. I'm having a heck of a time here. Multiply this by 1.53, and that will tell me what his value is. Now, I could also set up a proportion. You can do it that way, but we're going to start talking about scale factor a little bit more. So that's why I'm kind of doing it this way. My goodness. And so that would be his shoulder from point to point. All right, so that's how you could do it. Again, you could also set up a proportion for this. All right, if you wanted to do it that way, you could go 24 and then find a measurement that is of mine. That would be my height, 5.83 equals I don't know what his is over his height, which was 8.9. So then you could again cross multiply and get the answer. So there's a couple different ways you can do that. All right, and that's kind of what we're going to have you do. So this is the end of this thing. You're going to be back to the slideshow and have some directions to do to complete. So this is it, and bye.